Yeah, I mean, you call that right. And I support the ISV segment of customer. I work with a lot of ISV customers, and the interesting thing is that they've always been great in terms of streaming and real-time processing. But generative AI and agentic workflows just gives a different paradigm altogether, because now, as I said, I'm just using this term. It's no longer a data pipeline; it's an intelligent data pipeline. That's the heart of it, because you can, using a lot of by embedding a lot of intelligence in your data pipeline, you can do a lot of tasks beforehand and scale them out independently of whether you want to use a RAG or not, right? That's an important question that you should be asking in the first question. If you want to, then you can just implement the augmentation process within your ingestion pipeline or data pipeline itself. So that is an important advancement that I'm seeing, especially in terms of how you're ingesting the data and how I'm making the data available for my organization. That's one. The second thing I see a lot of these interesting implementations is intelligence on the engine side, where when I'm querying the data, I want the engines, or I want my interface to retrieve the data to be intelligent, where I don't really need to be a master of SQL. I don't really need to understand the entire concept of what I'm trying to access, right? And maybe some of this information may not be needed real time, right? I don't need a millisecond refresh from my dashboards, but I want to make sure that I put in a task that, hey, in the morning, just give me information of all the important events or all the security breaches that happened overnight as a security administrator. And I can just use that as my event-driven pipeline, or sorry, I can use that as an event-driven architecture, where that request can be queued along with other important requests, and based on the priorities that I assign, my architecture assigns, they can be executed by my engine. So my engine is not getting overloaded. I'm not spending crazy amount of extra money just to process a request which is not so important, which can be processed overnight, while I'm not babysitting every morning just to say like, hey, give me what happened. In the morning when I open my laptop, sit on my laptop, I will have that in my inbox. So that is the ease of use kind of a thing that you're seeing, along with the routing, right? The important thing is that not the single engine will allow you to do all the different things. The use cases may differ depending upon what you're trying to access as a source, right? If the requests are coming from my dashboard, then they need to be going to an engine which is performant to get the data in the low latency responses, right? But if there are requests coming in from the internal users, where me as a data warehouse administrator trying to see what is happening, or you as a machine learning engineer trying to see all the historical data so that you can build some more intelligent models or some more learnings into your existing models, those are not important. Those can be sent to not so fast engines, or the engines which are cheaper. And I don't need to get the fast response. So those are three important things that I see. One on the ingestion side, and how we are going to be evolving and making that data pipeline so cognitive. And the two other is on the access side of how I want to access and where I want to execute some of my access requests.
Yeah, so just to for clarify, when he was talking about the engines, he was talking about the compute engines or different engines.
Oh yeah, sorry. So compute engines and query engines, actually. Just to be precise, I say query engines because you can use anything, distributed engine or SQL engine. It's at the end of the day, it's a query engine.
Makes sense.